Okay, we're going to finish up section 3.4 and 3.1, hopefully. We're on problem 8. Graph the function f of x equals negative 3x squared plus 12x minus 11 by determining the vertex, the intercepts, and whether the graph moves up or down. That's method 1. So step 1 in method 1 is to look at our a value, and that's a negative number, so that tells us that the parabola opens down. The vertex, negative b over 2a, negative 12 over negative 6 is negative 2, and then f of negative 2. Negative 2 squared is 4 times negative 3 is negative 12, plus 24 is 10, minus 11 is negative 1. Positive 1. 2 squared, 24, minus 12 minus 11 is 1, yes. Okay, and the x-intercepts are located at negative 3x squared plus 12x minus 11 equals 0. Multiply both sides by negative 1. And then I use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Opposite of b is 12 plus or minus square root of b squared negative 12 squared is 144 minus 4 times 3 times 11 all over 6. Okay. So we get 12 plus or minus the square root of 144 minus 132 is 12 all over 6. And if we go to the calculator next, 12 plus root 12 all over 6. We can probably do that. 12 plus root 12 over 6. Okay, I'm looking at 2.8 of 5/8, and then 12 minus root 12 all over 6. 1.42. Okay, so the and then f of 0 is negative 11. So we've got 3 intercepts: 2.580, 1.420, and then 0, 1. So okay, well, I've got 2, 1 is the vertex. Negative 3 means it opens down. Here are my 3 intercepts. 2.580, 1.420, and then 0, negative 11 is way down here. That's the 3 intercepts on the graph. Okay. Problem 9, graph the quadratic function f of x equals 3 times x minus 1 squared minus 3 using transformations. That's method 2. Write the equation of each graph below the graph. Okay, so the first graph, we're always starting off with y equal x squared. I got 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4 on the graph. Y equal 3x squared. You always take care of the constant, the a value. Y equals 3 times x squared means I'm going to stretch the graph out by a factor of 3. So by stretching the graph out, that means that the graph should get closer to the y-axis on both sides. I'm going to stretch the graph out vertically. 0, 0 is on the graph. 1, 3 is on the graph. And all I'm doing is multiplying the y values by 3. So 1, 3 is on the negative 1, 3 is on the graph. Negative 1, 1 goes to negative 1, 3. 212 is in the graph, and negative 212 is on the graph. Okay, I'll stick with these three labeled points the rest of the way. Y equals 3 times x minus 1 squared means I'm going to shift to the right 1 unit, and okay, 0, 0 is going to be at 1, 0. 1, 3 is going to be at 2, 3, and negative 1, 3 is going to be at 0, 3. And then y equals 3 times x minus 1 squared minus 3 means I got to shift down 3 units. Okay, so negative 3 is on the graph, 2, 0 is on the graph, and 0, 0 is on the graph. And I've got each of the equations written below the graph. That's a pretty standard thing to do. Especially, make sure that you get this one done first. And then the last two can really be flipped order. But, I always do the left, right, second, or third, and then the up, down last. So, okay. Here's another one. Problem 10, we got graph the function negative 2x plus 2 squared plus 1 by using transformations method 2. Write each equation write the equation of each graph below the graph. Okay, so just like before, y equals x squared means that I've got 0, 0 on the graph, 1, 1 is on the graph, negative 1, 1 is on the graph, 2, 4 is on the graph, and negative 2, 4 is on the graph. Y equals negative 2x squared means that I've got a graph y equal x squared, but then I vertically stretch, and I also have a reflection about x because that's a negative. All I do is I simply multiply the y values by negative 2. Okay, so 0, 0 is 0, 0. 1, 1, we multiply the y value by negative 2. That puts you at 1, negative 2 on the new graph. Negative 1, 1 puts you at negative 1, negative 2 on the new graph. 2, 4 puts you at negative 2, 2, negative 8. Okay, down here. And then negative 2, 4 puts me at negative 2, negative 8. Next one, y equals negative 2 times x plus 2 squared. That's going to be a shift to the left 2 units. I know I'm going to the left 2 because of the plus 2 there. And so all these points have to move to the left 2. 0, 0 is going to be at negative 2, 0. 1, negative 2 is going to be at negative 1, negative 2. And negative 1, negative 2 is going to be at negative 3, negative 2. Okay, and then I go up one unit. So y equals negative 2 times x plus 2 squared plus 1. All these points from the previous graph I got to shift up 1. So negative 2, 0 is going to be at negative 2, 1. Negative 1, negative 2 is going to be at negative 1, negative 1. Negative 3, negative 1 is a negative 3, negative 2 will be at negative 3, negative 1. Okay. Problem 11. If an astronaut on the moon throws a rock upward with an initial velocity of 78 feet per second, the height of the rock in feet after t seconds is given by h of t equals negative 2.6 t squared plus 78t plus 5. Okay, how high is the rock after 1 second? Well, t is the time, and so 1 second, that's pretty easy. All I do is replace t with 1. negative 2.6 plus 78 plus 5 gives me 80.4 feet. Okay. Part B, determine the time at which the rock reaches its maximum height, and then find the maximum height of the rock in feet. Okay, well, so I need to calculate the vertex, because I know if it's a parabola opening down. I just need to know how tall it is. The vertex negative b divided by 2a, so that's negative 78 divided by 2a is negative 5.2. And then I want h of that. Negative 78 divided by negative 5.2 is 15. And then h of 15. H of 15 gives me 590. Okay, now they're asking for two things there. They're asking for the time to the max height and the max height. Well, t is the time, h of t is the height. Okay, so it looks like it's going to take 15 seconds for the rock to be at its highest point in the air. And at that moment in time, the rock would be 590 feet in the air. Okay? Tell you what, I'm going to stop the video right there.